Okay, so our next part is going to be talking about voltage drop. Naturally, having a ground or a power line lose its ability to transfer voltage is going to change the operation of whatever's on that circuit. So we can presume that if we have a battery and that battery is delivering power to a fuel injector, we should get all that power at that fuel injector, right? Simple as that. If 12 volts left the battery, 12 volts better be there for that injector. If we didn't, naturally that injector can't do its job. So we can see that we have two fuses that feed the injectors on my truck, right? 4 of them get from injector A fuse, 4 of them get from injector B fuse. What we're going to do is we're going to go from the battery positive to one of these injector terminals, right? We can do it at all, but we're going to do one, and we'll see what the voltage difference is between those 2 points. Now, what do? We take 1 lead of the DVOM, and we hook it to 12 volts at the battery positive, and the other one will go here, right before the injector at the connector on the power side. Now, if we look at way injectors work, right, power's there all the time. The computer supplies the ground, right? Each one has its own individual control. Therefore, it is a sequential fuel injection, right? So we're going to do a voltage drop from the battery to a fuel injector connector. And this is how much I love you guys, is these connectors are a pain in the butt. Okay, so we also are going to do it at the ground, right? So we're going to go from the ground to the ECM connectors, right? So our deal is this ground is connected to the ECM. We're going to go from battery negative to this ground. We're going to start the vehicle up. We're going to see what happens. Same thing. The ground, remember, power lines and ground lines are equally influential, right? They both have the same exact power over a circuit. So a problem on one side, problem on the other side, end result's the same. So we're going to go, now this one is on the back of the engine. So I'm going to try to get a jumper cable back there. I'll figure something out. And we're going to go to the battery negative, and we're going to see what happens when we start it. We're going to do that with both of these things. Now, if you want to see where this one's located, not this one, not this one. It was over here. Right, here's the transmission. Here's the engine. G103 is number 1, and number 1 is right here, somewhere up here, right? So I'm going to sit down and I'm going to try to find it, and we'll see what happens, right? So that'll be the 2 things I cover in this next video. Okay, so I've been having a lot of fun here. This is my connector for the fuel injector. Okay? If you look at your diagram, that's on the video, you'll see the pink wire is coming from that fuse. I used a back probe to get behind the connector. It only took me 10 minutes to finally get it in there. Right? So now what I'm going to do is I'm going to try to get this plug back in. I'm going to insulate this. In the lab, you would use J-kit, and you would J-kit this connector out so you can get access to it better, so you don't have to back probe, because in the classroom, if everyone back probed, they would destroy everything we own. Okay, so I am going to stop this. I'm going to get that plug back in. And as soon as I get that plugged in, I will resume, and we'll do the voltage drop on the injector. All right, so you can see the yellow connector that's back probed into the positive wire going to the fuel injector. That's into the pink wire. Again, in the lab, you're J-kitting between the injector and the connector for the injector, and then you can attach your stuff to it. You do not back probe in the lab. Okay, so that is hooked up. I do have battery power there. What we are going to do now is we're going to connect that meter between the battery, 12 volts, and that connector. And that will show us the difference between the two. Okay, so, again, if we do negative, it doesn't matter. Same thing. All right, so I'm going to start with taking the red lead from the meter and connecting it to 12 volts. Again, we're set for DC voltage, and the black lead I'm going to attach to that component. Right now the car is off. Therefore, it's showing 12 volts. That's the difference, right? We have ground through the injector and 12 volts at the battery. When I turn the key on, that's going to change. Now battery power is present at the injector, and now we see we got a 0.016 difference in voltage between the battery voltage and what's there at the injector. All right, so now I'm going to start it, and we'll see if that changes. All right, we can see that we are 0.03, and if we rev it up, right, stays pretty steady, and that's an acceptable range of difference. All right, so again, that's the difference. So we're sitting here at 14 volts. We are 0.029 volts lower at that injector. All right. Now another area that was a miserable experience is that jumper wire right there is attached to that ground coming from the ECM, that's G103. We are going to do a voltage drop test between that point and ground. So now we're going to take the meter and we're going to take the lead off of that, off the injector. Let's disconnect all of our stuff so we don't have a problem. Now we're going to take and we're going to clip our jumper wire to the battery negative, and we can click that to the red lead. And then the other lead will go to that connector that's attached to that ground wire. Right now we can see there's no difference to it. Now when a ground problem happens, when there's an electrical load on the circuit, that's when you'll see it pull away. All right, so when we start it, that cranking time is when it's at its absolute highest. And if there was a problem with that ground, we would see it get really big. Okay, we see right now we have, but you guys saw the voltage when I first cranked it. That's the number that would be the important one. Right now, this is still an acceptable range. We don't want to see too much difference between the two sides. Right? So, again, we rev it up. We look for a change. If it's not a change and it's low like that, then we are adequate. Okay, so that was checking the integrity of voltage drop on the power side and the ground side. Now I'll tell you about a past experience. A million years ago, I worked on a 1988 Chevrolet Celebrity, 2.8 liter. And you would take the car and you would lay into it, and it would wind up in RPMs. and all of a sudden the vehicle would start shutting stuff off and the car would die. When I checked the voltage drop on the ground side to the PCM, it totally disappeared under load. All of a sudden it went from 0 for ground to 2 volts, to 4 volts, to 6 volts, to 12 volts, and naturally no ground to the PCM. So I had to take that ground wire and supply my own ground to the PCM to fix the car. So that's where you would check voltage drop, right? It could be on either circuit. You want to see it stay the same. All right, so I wanted to recap. We did a voltage drop actually between this battery feed wire and battery positive. Okay, so this is fuel injector number 1. I back probed this pink one, and we compared it to the battery. Now I want to show you for our ground. Actually, let me go back to this one. Right, this is G103, so now we compared this connection point to the battery negative. And here's the location of that one once again, right? It's way back here. Number 1 is the point of it. Right, so just so you know, maximum voltage drop allowed, 0.1 volts, 0.1. So when you looked at that ground, when it cranked, when a full load of the starter was on it, it went like 0.252, something like that, which was excessive during that time. That's when grounds deteriorate.